All right, so we're back, and apparently it's not glitchy anymore. So again, the thing in red up here is the conjugate. You got to, that was one question. You got to multiply numerator and denominator by the conjugate. Middle terms drop out real quick. Square root of 49 is 7. 7 take away 4 is -3. So your final answer is this: 5 radical 7 minus 10 over -3. Okay. Are we okay? All right.
Yeah.
Couple things here to talk about. Sometimes people will multiply top and bottom by -1. Why? I don't know. Okay. But watch what happens if you do that. This turns out to be -5 radical 7 plus 10 over +3. This answer and this answer are exactly the same. There's no difference. Okay. Except some people think this is prettier than this. Okay. I will accept either one of these. It doesn't matter to me. My mantra is do the least necessary to get 100% credit. So this is good, stop here. But if you're into making things look pretty, then this is okay also.
I was putting mine out in front of the line. Is that okay?
That in so negative of, and you have the 3 down here. Yeah, that's fine. That's okay.
What if
Somebody
the
else
negative was
started.
next to the? Sorry.
Go ahead.
What if the negative was next to the 3?
Well, it was.
As the final answer, that would be okay.
Yeah, this one is okay,
cool.
or this one was okay, or the one that Philip suggested is okay.
Awesome. Okay.
Okay.
Isn't 7 minus 4 a +3 though?
Yeah, I was just about to ask that.
Well, crap.
Why do we have a -3?
Because I'm an idiot. And therefore, all of that was a waste of time.
That really confused me.
Sorry. Okay.
It's okay. It's not your fault.
Yeah, it is. That is my fault. That was a bad mistake. That was a horrible mistake.
So I went straight from doing the conjugate to going straight to 7 minus 4 because I could do it in my head. Is that going to be a problem on the exam?
Nope. Think of it this way. What you're showing, do you remember dose, difference of two squares, factoring? If you had a squared minus b squared, it was a minus b times a plus b. Do you remember factoring a dose problem? It always broke up that way.
Yeah.
Okay. Well, we're going backwards. We're saying if it's a minus b times a plus b, it will turn into the first number squared minus the second number squared. And there'll be nothing in the middle. So this is just, in what you're doing without realizing it, is you're doing a variation of dose factoring in reverse. So if you had, I don't know, square root of 3 minus 2 times square root of 3 plus 2, then because this is the dose pattern, this will be the square root of 3 squared minus 2 squared. Okay, so that's 3 square root of 3 squared minus 4. Answer is -1. So you're using, because you've seen a pattern, the dose pattern to shortcut your way through, and there's absolutely no problem with that at all. That's wonderful. I'm glad that you saw that pattern.
I just didn't see any reason to times the two together because it's a square. So
right,
you're going to get rid of them anyways.
Well, you need to be careful though. Okay, this only works when it was a minus b times a plus b. If it were a, let's say, plus b times a plus b, if they're exactly the same, then the dose pattern fails and you have to multiply them out. So you need to be careful that you're using the shortcut in the appropriate way. Okay,
Got it.
but other than that, you're okay. All right. And thank you to both Philip and Carmen for letting me put the wrong answer up there, letting me make a fool of myself and then catching me later. I appreciate that. I will remember.
I was trying to say something earlier.
Yeah, sure. Okay.
I just
Sure.
wrote it on because I trust you.
Wait a minute. Never trust me. Okay. What's the new mantra? Never trust a white old man or an old white man or something, whatever. No, don't trust me. Okay. So this one, this is not exactly what was on last night's quiz. Okay. It was a square root equaling a square root, but the method is the same. How do you get rid of a cube root? Well, you cube power both sides. Whoops, cube power, idiot. Okay. And that was going to cancel all of these. So you get 3x plus 7 equals x squared minus 3. Last night on the quiz, I can't tell you it was number 10 because the problems got scrambled up, but there was a problem that was a square root equals a square root. And all you did is square both sides and that killed the square roots. And then you work with this problem. Okay. So this one, because it's a square, we make it equal 0. So we take away 3x from this side, take away 7. We get 0 equals x squared minus 3x minus 10. Take away 3x, take away 7, whatever. You get 0 equals, okay, by whatever method you wish, you're going to factor this, the AC method, the belly button method, whichever method you want. It'll be minus 5 plus 2. So x minus 5 equals 0, or x plus 2 equals 0, x equals 5, x equals negative 2, solution set 5, and negative 2. And because it's a cube root, there are no restrictions. Remember, we have all these stupid rules for the square root of something or the fourth root of something. We have the rule that the inside has to be positive and the answer has to be positive for even indexes. Okay, but with a cube root or a fifth root, we don't have any restrictions. So that almost guarantees that whatever answers you get are going to work for a cube root. Now, if this had been a square root originally, things might be weird, but not for a cube root. I believe both of them check. All right, I want to use the second example to show you something, but does anybody have any questions about either of those?
Mr. Foster, so
Yeah.
I know this is really annoying, but your main camera is lagging again, but your strangely awkward camera on your desk is working. If you could just move your chair and move it down slightly, we could just use that one. And we just need a pin. If you guys go on the gallery and pin it, it'll bring it up to full screen.
Well, the problem is my good camera, when I, so wait a minute, what you're saying,
Position it higher so we can see the full board.
Like, yeah,
maybe?
you don't have to do anything. We can pin it. You just have to move the camera down slightly.
Yeah,
move the camera down,
there you go.
Yeah,
Yeah,
perfect. Yeah, that's good.
and then you guys can all see it. So what do?
So whoever's watching, if you go to the gallery setting and you pin the awkward angle camera, it'll bring it up as full screen. You have to click on it and then press pin.
Okay,
Your audio isn't lagging, and we can read like all your letters are out there and clear.
so
Thanks.
what's, I
That
don't
does
get it.
work. That totally works.
Yeah,
Okay.
so we're good. Yeah, you can keep on going.
All right, well, if anybody has a question, chat Mitch and see what happens. Okay, I'll just do whatever you guys tell me to do. Okay, whatever.
That
All
works,
right,
Professor.
okay, it does. All right. So I'll just keep going. If you can't see, let me know. All right, I've got my calculator. I want to show you something. It's kind of a dangerous thing. Right, you have a button on your calculator called tan and tan -1. And right above it says syssolve. Now this is for the TI-36. Okay, this is for the TI-36. So if you click on syssolve, wait a minute, quit. And this time you do have to go, well, it would help if you had a brain. Okay. No, not syssolve. Polysolve. I'm totally out of it. You guys have flummoxed me. Sorry. Scratch all that. I don't want tan and inverse tan. I want cos and inverse cos. So you got cos -1 and cos that button. That's the one I want. And then above it is something called Polysolve. That's the button I wanted. I'm sorry. And if you push that, okay, you see number 1 is ax squared plus bx plus c equals 0. Okay. So let's say I wanted to solve this problem. So in this problem, a equals 1, okay, b equals -3, c equals -10. So on your calculator, if you press enter on number 1 or just press number 1, okay, a equals 1, b equals -3. I'm inputting it here, -3. Remember, on the negative, you have to input it as -3, like that. It's nitpicky. C is -10. And then you move down to solve. And it tells you x sub 1 is -2. X sub 2, if you go down arrow again, x sub 2 is 5. And those are the two solutions. Okay, you can use that. That will solve any quadratic equation, any of them. Now, here's the problem. What if I say I need to see your steps? Then you can't use this as your final work. You can certainly use this to check your work. Okay, I can't stop you from that at all, but I would want to see your steps. So if the instructions say, show me your work, show me your steps, blah, 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 blah. Okay, then you got to show me this, but you can certainly check it on your calculator. But if I tell you in the directions that it's okay to use your calculator, then once you get to here, you can use your calculator to jump all the way to here. So everything comes down to the directions. If you're unclear, you're always safest to show your work. If you're not sure, you can't get a hold of me, you don't know what to do, okay, cover your rear end, CYA, okay, show your steps. But nobody is stopping you from checking your work. Your calculator will do that. And I think several of you have been using it anyway, but I just wanted to make sure everybody has that.
And how
Okay,
do you do that? How do you do that one more time on the calculator?
on your, this is on the TI-36X.
36.
Okay, the one we've been using, or I've been using again. Okay, so you find the button called cos -1, and right above it, it says Polysolve. So you press second Polysolve, and you should see Number one looks like this. Number two is a cubic equation. Those of you going on to Math 116, you will want to use that in 116. Okay, so you press number one here, and then it's just going to go through a list asking you what's your A value, what's your B value, what's your C value. And then just use your down arrows to solve, and then it'll find X1 and X2. Are you okay?
Yep. Thank you.
Okay. Yeah. Anybody else? Okay. Then those are the two that I saw that the majority of people had trouble with. And when I say majority, I mean 85% of the people got these right. Only 15% missed it. Okay. So you guys did great on the quiz. Hopefully you'll do great tomorrow night. All right. I want to give you 3 more problems to try. Okay, 4 more problems. Okay, so try this problem, 5x over the cube root of 12xy squared. That would be number 3. Number 4, 3 radical 2 plus 4 radical 3 quantity squared. Okay, let's do those 2 first, make room. Let's pause, give you guys about 4 of those. Oh, crap. Okay, the rule is you can't have a radical in the denominator, but it's a cube root. Remember, to get out of a cube root, you have to have a cube power. That's the rule we're using. To get out of a cube root, you have to have a cube power. Cube root, cube power, cancel out, you just get x. So our game here on this first problem is to make everything have a cube power in the denominator. So you may do it slightly differently. It's okay as long as we all get the same answer. I see this as 2 squared times 3 times x times y squared. I factored 12. 12 was 4 times 3, but 4 is 2 squared. Now I'm looking at this going, okay, what can I do to make everything cubes in the denominator? So I have a 2 squared, so I need to multiply it by a 2 to the first. Now I'll have 2 cubed. I have a single 3. I need to multiply it by 3 squared. Now I'll have 3 cubed. I need to multiply it by x squared to get x cubed and y. Okay, but I need to do the same thing to the top. Always, whatever you do to the bottom, you do to the top. So that's 2 times 3 squared times x squared times y. Okay, so on top, this becomes 5x times the cube root of, if you put this together, 2 times 9 is 18, x squared y. If you put this together on bottom, okay, you can, it's okay to skip this step. I like to put it in, but you have the cube root of 2 cubed times 3 cubed times x cubed times y cubed. I like to put that step in for me personally, because it ensures me, it gives me a check. Do I have cube powers inside of a cube root? That's like my last second check. I do. So this will become x, 5x times the cube root of 18x squared y over, I'm going to have 2 times 3 times x times y. And the only thing I have to do to make it pretty, is multiplied together 2 times 3. 18x squared. Did I find the glare? Yes, I did. I found the glare. Good for you, Foster. 5x cubed root 18x squared y. Okay, over 6x y. Oh, what's one more thing I should have done besides doing 2 times 3? I forgot.
The other numbers from the start, right?
Wait, say again? I'm not sure I caught that.
Shouldn't the denominator be 12 also, or no?
No, no, because I didn't multiply by 12. I
And you can
multiplied.
cancel out the x's.
Yeah, that's what I was going for. The x's should have canceled. I should have canceled the x's out probably right there. So they don't even have to be there. The denominator is not a 12. That's a for sure. If you had, then you have what, 48, 104 in there, I think, in the cube root, and that simplified and came out and did some more reducing. So you multiplied, instead of breaking the 12 down like I did, you multiplied it by 12 squared or something.
Yeah, I just broke it down wrong.
Yeah, you got too big of numbers. My method avoids huge big numbers. If you break down the 12, then you can see the least necessary to fix this problem up. Okay, your method isn't wrong. It's just got huge numbers, and then you have to simplify it, and you're screwed.
Gotcha. Thank you.
Yeah. So anyway, there will be some on tomorrow night's test on the multiple choice and on the show your work part that ask you to rationalize a fraction. Okay. And most will be square roots. So those are easy, but there'll be a couple cube roots and maybe a fourth root. Okay. And it's the same technique, same idea. But most of the problems will be square roots because that's what we see most often. But just because I want to see if you know what you're doing, I'll throw a cube root at you and maybe a fourth root at you. Okay. And we've already done one. I'm not going to do another one. But like if we had 7 over the square root of 2 plus 5 or something like that, that's another kind of get rid of the radical. That's the kind where we had to multiply by the conjugate, square root of 2 minus 5 to top and bottom. So a bunch of these, 1 or 2 of these on tomorrow night's quiz or test rather. All right, I'm going to run into my own work here. I might have to erase this. Are we doing okay? Anybody want me to wait before I do the other side?
Wouldn't you have to break down the 18?
Remember it's a cube root. Okay. And when you look at 18, it was 2 times 3 squared. But by looking at it back here, you know that there's no cubes inside of 18. There's no 3 powers. So you knew you didn't have to do that. Your intuition is correct. Yes, you should try to simplify the square root of 18. But by going back up here and looking at it, I can, in factored form, I can see that it doesn't simplify. Okay, anybody else? Okay, then this one, you have to write it twice, 3 radical 2 plus 4 radical 3 times itself, 3 radical 2 plus 4 radical 3. Okay, there is a formula shortcut that some instructors want you to memorize, and I find it a useless waste of time. How you multiply this is your business. Many people that I've talked to via email, okay, when the problems start getting ugly, they like going to the matrix. Okay, to help organize their work. Okay, so 3 radical 2 times 3 radical 2 is 9 radical 4. 3 radical 2 times 4 radical 3 is 12 radical 6. 4 radical 3 times that is another 12 radical 6. And 4 times 4 is 16. Oops. Radical 9. So what happens here, back to here, this is 9 times 2. So this is worth 18. Okay. This is 16 times 3. The square root of 9 is 3. So this is worth 48. So when I try to add like terms, 18 and 48, that makes 66. 18 and 48 make 66. And 12 radical 6 and 12 radical 6 make 24 radical 6. Now, there's a bunch of different ways people can show their work. All of that is good. Did you get this? I'm happy. Questions?
Sorry, just a quick question again. So I just went straight to 18 from 6 times 2. I just did it in my head. Is that okay?
6 times 2? Or do you mean 9 times?
9 times 2, sorry.
Yeah,
9 times
okay.
2.
Yes, that's fine. What you're using. Look, here's what I do, and this may help people. I know that square root of 2 times square root of 2 is square root of 4, which reduces to 2. Now think about that. Radical 2 times radical 2 eventually becomes normal 2. Okay? Radical 7 times radical 7 is radical 49, which becomes 7. So radical 7 times radical 7 becomes normal 7. That's what I use when I multiply inside, inside, outside, outside. I know that radical 2 times radical 2 becomes normal 2. So right now, when I did 3 radical 2 times 3 radical 2, 3 times 3 is 9, which is what you said. And radical 2 times radical 2 is normal 2. 9 times 2 is 18. So I'm kind of explaining to everybody else what you said, but what you said is 100% okay, no problem. Okay. I don't even care if you don't show me this or you don't show me something else. If you can do all that multiplication in your head, more power to you. Okay. Just don't get any anesthesia like Lindsay has. Okay. Because then you can't do it in your head. Or maybe
I
you
think
can.
she's gone already.
She's gone already. Okay.
No one's here. I'm still watching.
Okay. All right. So we can't pick on you yet.
I really want Mitch's dog to come back though.
Mrs. Who?
Bentley,
What?
1 second.
Mitch has the cutest dog in the whole world. Like I had switched screens for a minute because I was like, oh my God, this dog.
What kind of dog is
Sorry, my babysitter just told me I shouldn't be talking during math class.
it? Yeah, well, probably not, but oh well, that's me. Where's the dog?
He's sleeping. He's a little sleepy.
I'm just having trouble leaving, sorry, because I switched.
Huh? I'm sorry. What kind of dog is he?
He's a Chihuahua Italian Greyhound mix.
Oh, my neighbors across the street have an Italian Greyhound, also not the mix. Yeah, my puppy just died last night. I'm kind of.
Oh my gosh, I'm so sorry.
Yeah, well, she was 14. She was 14 and a half. So yeah, it was right after class. See what math does to you. All right. So anyway, back to
You made your
your
dog do math?
Yeah. Okay. She goes 1 treat, 2 treats, 3 treats. I made her do math.
I love it.
No. Okay. So I want to do one more. Then I want to do word problem. Then I want to call it unless you have your own questions. Okay. One more review, one more word problem, and then open it up to you guys. X minus 1, you're solving this. I'm sorry. X minus 1 over 2x plus 2 equals x over x plus 1. I want you to solve this any way you can, and it's okay to use calc on the quadratic. So let's pause and have you guys try that. I just saw a fast way to do this. I made this problem up and I just saw a way to get around everything I wanted to show you. But this is a proportion, and I was hoping that you guys would see it as a proportion and cross multiply. Okay, that's the fastest way out of this. Yeah, you could use the LCD and all that other stuff we've talked about. But seeing this as a proportion is sometimes the best way. And in a proportion, you simply cross multiply. So your work would look something like x minus 1 times x plus 1. That's crossing these ways and multiplying equals x times 2x plus 2. That's crossing the other way. Okay. This, when you multiply it together, should be x squared minus 1 because it's a dose problem. Or go to your scratch paper or use the matrix or do whatever. But it turns out to be x squared minus 1. This is 2x squared plus 2x. Okay. Because it's a power of 2, that tells us automatically it's quadratic. We must make it equal 0. Okay, so we take away x squared from both sides, add 1 to both sides, and we get 0 equals x squared, 1x squared, plus 2x plus 1. Okay, which is totally different than what I had in my notes.
Plus 2?
All right. Plus 2.
Wouldn't it reverse? You'd have to move it to the other side.
No, because my 2x squared is already positive. So I want to leave the x squared there to keep it positive. If I move the 2x squared over here, I'd have negative 2x squared, and I want that to maintain positivity as much as I can. Okay, yes, no? I think I'm okay.
Yeah.
All right. So this factors, you could use your form calculator. So this is, I believe it's x plus 1, x plus 1. Okay, set it equal to 0, x plus 1 equals 0. So x equals negative 1. Now, if you use your calculator, you still should have gotten negative 1. Are we okay? All right. In a fraction, you always have to worry about the restrictions. In a fraction, you always have to worry about restrictions. In a fraction, the denominator can never equal 0. Now, I know you're all almost as lazy as I am, okay? And I know you don't want to plug in negative 1 everywhere for x, but you can plug it in there for x, just in the bottom, in the denominator. And if you plug it in there in the denominator, you get this to equal 0. So this becomes a rejection. Okay. You've just rejected your only possible answer. So there is no solution. Okay. So I wanted to remind you of two things with this problem. Number one, if you have a proportion, cross multiplying is 99% of the time the easiest way to get the problem out of fractional form into a more normal looking form. That was method number one. I wanted to reinforce cross multiplying. There will be a couple of those. Now, you could multiply by the LCD and all that other stuff, get the same answer. But it's easier this way. The other one I wanted to do is I wanted to remind you to always check your answers. On a fraction, okay, check it in the denominator. At the very least, check it in the denominator. If you have a fraction anywhere in your problem, does my answer make my denominator undefined? That's the question you have to ask. Okay or not okay?
Okay.
Okay for everybody. Okay. Then can I erase this? Okay, I don't hear anybody yelling at me. Okay. I want to do one other problem off of the worksheet we had last night. If somebody still has it available and can put number 6 into the chat for everybody, I'll write it up here, but it might be easier if it's also in the chat. This is worksheet number 6 and my pen. Do I have to change my pen? Yeah, damn it. Sorry. I'm using up ink. There's no tomorrow. Actually, there is none. So number 6 says a rectangle has area of 36 feet squared. If one side is 5 more than twice its adjacent side, okay, find, I'll abbreviate it, but it says shortest side. Okay, rectangle has an area of 36 square feet. If one side is 5 more than twice its adjacent side, find the length of the short side. Okay, here we go. So we start with a rectangle, okay, and we have to worry about the English. Somebody has to be X. So this, let's call this side X. Somebody has to be X. Okay, what does the word adjacent mean? What does it mean to be adjacent to something?
The perpendicular
Next
side?
to.
No, next to.
Oh.
Adjacent means next to. So if this is one side, this is its adjacent side. It just means the side next to it. That's all adjacent means. Okay, adjacent side is next to it. So what's it say about that? it's 5 more than twice its adjacent sides. So these two sides are adjacent to each other. So this is 2x plus 5. So the adjacent, this side is 5 more than twice this side. These two would be called adjacent to each other, next to each other. So those are your two sides. And that's the English, 5 more than twice its adjacent side. 5 more than twice means 2 times, this other side here. So that's got to be your setup or your sides. We also know that area is 36. Okay, so using this, using the formula, area is length times width. We know that 36 is, and by the way, it doesn't matter who the length is and who the width is. Nobody cares, but it's 2x plus 5 times x. Length and width are interchangeable. Okay. So this becomes 36 equals 2x squared plus 5x. Okay. Again, I'm learning to hate these powers of 2. It means I got to make it equal 0. So I have 0 equals 2x squared plus 5x minus 36. Now, you can use your calculator on this. Let's make sure we can. Okay, so I'm going to write use calc here because I didn't say you couldn't. So if I use my calc, what do I get? Turn it on. Okay. A is 2, B is 5, C is negative 36. Solve it. Okay. My calculator tells me that x sub 1 equals 3.1729. Okay, come down. X sub 2 equals negative 5.6729. Okay. But in this problem, X is the side of a rectangle. You can't have negative lengths. So this is a reject. This one. So you'd say something like short side is I didn't tell you what to round. Okay, I will tell you specifically when we get to the chapter 9 tests what to round to, but 3.2 meters or feet, excuse me. My unit is feet in this problem, feet. Okay. Questions on that problem? Okay, let me get some new ink. Is that okay with everybody on that problem? Between that worksheet I gave you and practice on mom, you should be okay. When we hit the chapter 9 test, there's going to be 1 or 2 word problems at most from chapter 9. There will be a few more word problems from chapter 10, but we haven't even started 10 yet. Okay. Tomorrow.
What time is that test start?
I'm going to show you right now. So on Thursday, which my pin is not working. Okay, Thursday on Canvas at 6 p.m. It's on Canvas. Okay, you do not have to log in to me on Zoom. I'll be here if you're having trouble, like getting your test and stuff like that. But you don't have to log in if you don't want to. Okay, part one is, it says something like Math 96 multiple choice. Okay, you don't have to show me any work at all. Just your answers. Okay, and I believe you have 60 minutes. Okay, part two. Again, these are all on Canvas. Part two is exam number 3. Yeah, number 3. I think that's right. No, this is exam number 2, isn't it? Is it? I'm
Yeah.
confused.
Yeah, number 2.
Yeah,
Yeah.
this is exam number 2. I'm
Those.
Dose. Okay, thank you. Yeah, I've been working on exam number 3. Yeah, Dos Equis. Okay, yeah. Modelo, please. Okay. Exam number 2, whatever it is, this is show work and steps, whatever, and this is upload your work or steps. And both of these are due by 11:59 p.m. So just like exam number 1, okay, 2 parts to it, a multiple choice part and a show your work part. The multiple choice is timed, show your work isn't, but everybody is due by 11:59. Is that okay with everybody?
Yep.
Okay.
Yes.
If I'm done for the night, if you want to go away, Lindsay, if you want to go drool or go fall asleep, that's cool, whatever. If you want to stick around and ask me some personal questions for you, ones that you had trouble with in the homework, whatever, I'm going to turn off the recording now and you guys can go home and just get ready for tomorrow night. So hasta bye-bye, guys. Those of you who want to.